in this last class we have been discussed about the DHO, damped harmonic oscillator. Let's just figures. So another one is that forced oscillations. So here let us assume that an actional periodic force. Periodic means repeatedly the force which is going to be applied on a damped harmonic oscillator DHO. So that the oscillating system we can call it as a FO, forced oscillator. And these oscillations you can call it as a forced vibrations. So here these forces that acts on a particle which are three types. That means one is that restoring force. This is we have been discussed in the case of DH also, damped harmonic oscillator also. So the restoring force which is proportional to the displacement, but which is opposite the direction. That means minus k is a constant, spring constant, force constant, where x is the displacement. Whatever. Next, another one is that frictional force or damping force. So here, which is also proportional to the velocity and which is going to be x in opposite direction. That is minus r. Where in some textbooks they are going to write it a capital R. So you need not to worry. So whether it is a capital R or small r, whatever it may be, both are same. R is the frictional force per unit velocity. Next, last one is the applied periodic force. So applied periodic force. So that there you can write it down, which is a F sine omega. Okay, sine wave. Already told you 0 to pi, pi to 2 pi. So 0 to 2 pi. Again, at pi 2 pi to 4 pi repeatedly, which is going to be takes place. That's why here a periodic force, which is going to be represented like a sine wave. That's why we are going to be considered it as a F sine omega. So where capital F is the maximum value of the force, and here the total force by adding all these restoring force, frictional force, and applied periodic. By add these three, so what you will get here? Minus kx minus r into dx by dt, not dx by dy. Okay, correct it. Dx by dt plus remaining is f sine omega. So we know pretty well Newton's second law F equals to ma. By equating this equation, m into d square x by dt square equals to minus kx. Here also print mistake. This is not kr. Is it clear? Okay. Here you can correct it as a minus kx minus r into dx by dt plus f sine omega. So by solving this equation, by taking negative signs into left hand side, so that m into d square x by dt square plus r dx by dt plus kx, which is equals to f sine omega. Or else by dividing with m on both sides, you can have d square x by dt square plus r by m into dx by dt plus k by m into x, which is equals to f by m into sine. Okay. Up to here, is it okay? Hello?
Yes, sir. Yes, sir.
Yeah. Yeah. You need to do the practice.
Yes.
Yes. Okay. Some corrections are there. I already told you. Better to go. Next, let us consider in this equation r by m is a 2b, and as well as k by m is omega naught square, and f by m is 1 force per mass. So here we have to substitute all these values, so that you are getting here d square x by dt square plus what is r by m, 2b into dx by dt, and what is k by m, omega naught square. X should be there. Okay, that is not written in this equation, print mistake. And here f sine omega t. So this is the differential equation of the motion of the particle. So you need to derive the what is the solution for this. So the solution. Let us consider that x value is pretty well. X equals to a sin omega t plus phi r minus theta, where a is the amplitude of the vibration, omega is the angular frequency, and theta is the angle by which the displacement x lags behind the applied force. So that what is the applied force here? F sin omega. That is a periodic applied force, F sin omega. So by applying this, but the displacement which is lagging behind this force. That's why here we are considering this equation. So by differentiating this 4.2 equation, dx by dt equals to a omega sin theta is cos omega t minus. Again, second order differential equation, that is d square x by dt square equals to cos theta is minus sin theta. That's what here a omega is there. Again, if we are going to be differentiating this cos omega t, that is omega remains there. That is omega into omega is omega square. Cos is minus sin. That is minus a omega square sin omega t minus theta. So substitute in above equation. So what you will get here? What is the d square x by dt square value? Minus a omega square sin omega t minus theta plus r by m. What do you say? 2b. That is here in this equation. Where do you substitute in this 4.2b into dx by dt? So 2b into what is dx by dt? A omega cos omega t minus plus what is that remaining? Last is omega naught square a sin omega t minus t. What is the last term? Omega naught square x is there. Okay. So here omega naught square, what is x value? A sin omega t minus. So a sin omega. That equals to, so f by m, we are saying small f here, which is not 1 in this equation. Capital F by small m is a small f. Write it down. So many mistakes are there. Correct it. Plenty mistakes, not by the other. So here f sin omega. So that sin theta can be written as here f sin omega t minus theta into plus theta. So what I am writing here, right hand side portion, can we write like this? Minus theta plus theta, if it is going to be cancelled here, the same thing is going to be written. Is it clear? Right hand side. समझ में आ रहा है जी? Hello.
Yes, sir. Sir,
Hello.
hello, sir.
Yeah. Tell.
సార్ యాక్చువల్లీ మీరు ఎస్హెచ్ఎం సింపుల్ హార్మోనిక్ మోషన్ కి పీడిఎఫ్ చేసినట్టు దీనికి కూడా ఈ టాపిక్ కూడా ఉందా సార్ మాకు హెల్ప్ అవ్వడానికి?
నేను పంపిస్తాను, నోట్స్ పంపిస్తాను, పిల్లలది నోట్స్ పంపిస్తాను. ఓకేనా?
ఓకే ఓకే సార్.
యా, ఐ విల్ సెండ్ యు నోట్స్.
టెక్స్ట్ ఉన్నాయి కదా సార్, కొంచెం
యు నీడ్ టు అండర్స్టాండ్ the equation portion. That's what I am going to do.
ఈక్వేషన్ ప్రాసెస్ అర్థమవుతుంది సార్, మాకు కొంచెం తెలుసు కదా, మ్యాథ్స్ లో చేసుకోవచ్చు, కానీ కొన్ని మిస్టేక్స్ వల్ల మేము కొంచెం వెనుకకు అవుతున్నాం సార్. అట్లా
అర్థమవుతుంది కదా ఈక్వేషన్?
అర్థమవుతుంది సార్.
చెప్పండి, నేనేదో మొత్తం నాకు నేను చెప్పుకున్నట్టు కాదు.
అవునవును సార్. సార్ ఇది మీ వాయిస్ కూడా కొంచెం లో అవుతుంది సార్ మాకు మధ్య మధ్యలో.
Actually, I am at college, so today is not holiday. That's why I'm taking.
Okay.
A little bit disturbance is there.
Yes, sir. Yes.
So in this equation, why I am going to be stressing out means this is important as a question. That's what I am repeating. So is it clear now? F sin omega t minus theta. So in above equation, A, here sine omega t minus theta is there, and here also. Just want to see here. A omega naught square minus omega square sine omega t minus theta. Where is sine omega t minus theta? Here is there, and also here is there. So that omega naught square, this one, minus omega. So minus is here is there into sine omega plus 2 beta a omega, same portion here, right? Which is equals to what is that? Sine omega t minus theta plus 2. So here sine A plus sine A plus B. What is the formula? Sine A cos B plus cos A sine A. Okay. Same is written. ఓకేనండి.
ఓకే
So here right hand side is this one. Sin A cos B, where it is this equation, sin A plus B, sin A cos B cos A sin B, but F is there, small f along with small f. Okay.
Side
Yeah.
లో
Yeah, tell me.
ఎఫ్ సైన్ ఒమేగా టీటా మైనస్ టీటా అని ఇచ్చారు కదా సార్, ఒమేగా టీ మైనస్ టీటా ప్లస్ టీటా కదా సార్. అవి ఇన్సైడ్ లో తీసుకుంటే కాస్ కి వచ్చింది కదా సార్. కాస్ ఎలా వచ్చింది సార్? డిఫరెన్షియేటింగ్ కాదు కదా సార్.
అట్లా కాదమ్మా. నేనేం చెప్పినాను ఇక్కడ? ఈక్వేషన్ చూడు, సైన్ A plus B, sin A plus B. Okay, what is A? Omega t minus theta is A. Theta is B. Okay, what is the formula for sin A plus B? Tell me.
సైన్ ఏ కాస్ బి సార్. ఓకే సార్, ఓకే సార్.
Sin A cos B plus cos A sin.
సైన్ బి సార్.
Okay na?
ఎస్ సార్. ఓకే సార్.
Right. So the same thing we have been substituted. So here in this equation, by equating some terms here, that is A into, again we go for this, A into, here sin omega t minus theta is there. Where is sin omega t minus theta? And this is LHS, this is RHS. Okay, LHS term is there, A omega naught square minus, which is equals to, what is the RHS value? Where is sin omega t minus theta? This one. So remaining is F cos theta. Is it okay now? LHS equals to RHS we are doing. Okay, first term.
Okay, sir.
Okay, so that here sin omega t minus theta, here also sin omega. Both are get cancelled. Remaining is this 4.3.
In the,
అర్థమైందండి?
in the second term,
Yeah.
omega to be a omega and is
Yes.
remaining.
2b
Yes, sir.
omega. Here this one and this one get cancelled. Remaining is
Sin.
2b omega is f sin. అర్థమైందండి?
అర్థమైంది సార్.
నెక్స్ట్ మీరు ప్రాక్టీస్ చేయాలి. బై హార్ట్ చేస్తే ఫిజిక్స్ రాదు. సో స్క్వేరింగ్ అండ్ యాడింగ్ దీస్, ఈ రెండు ఈక్వేషన్ ని స్క్వేర్ చేసి యాడ్ చేయండి. విచ్ వన్? 4.3 అండ్ 4.4. సో ఏ స్క్వేర్ omega naught square minus omega square whole square plus 2b a omega whole square. ఓకేనా? 2b a omega whole square స్క్వేర్ చేస్తే ఏమొస్తుందండి? 4b square a square omega square. This one. Okay.
Okay, sir. In the next step, you complete,
Yeah.
sir.
Yes.
After that, we are
So right hand side, what is right hand side? F cos theta whole square plus f sin theta whole square. So that f square is there, cos square theta plus sin square theta is 1. Okay, this one. F square cos square theta plus sin square theta. What you will get? F square into 1 equals to F square. Okay na? ఇది రైట్ హ్యాండ్ సైడ్. So simplifying this equation, in these two, here a square is there, here also a square. By commoning this a square, what you will get? Omega naught square plus omega square whole square plus 4b square a square omega, which is equals to f. Okay, ఈ ఈక్వేషన్ అర్థమైందండి? If you respond, I can go
Yes.
thoroughly, quickly I
Sir.
can.
F తర్వాత ఇక్కడున్న బ్రాకెట్ అటువైపు డివిజన్ అవుతుంది.
Yes, a square equals to here
F.
f square is f square. Print this. So later on a equals to square root అవుతుంది. అవునా కదండి? So that f square means f you will get, this is the square root of omega naught square minus omega square whole square plus 4b square. This is the 4 point. Up to here it is clear. Is it clear?
Yes.
4.5 వరకు మీకు క్లియర్ ఉంటే I can go for the other. Next, by dividing 4.4 by 4.3. Where is 4.4 by 4.4? These 4.4 divided by 4.4. What you will get? Tell me. Tell me అండి, ఆన్సర్ చెప్పండి నాకు. హలో, 4.4 divided by 4.3. What you will get?
0.1, sir. 0.1, sir.
జీరోనా?
Sorry, sir.
0.1 ఏంటమ్మా?
Sorry, sir.
నేను
Sorry.
ఈక్వేషన్స్ అమ్మా,
tan theta
Tan theta is equals to 2 by omega square minus omega square.
0.4.4. Yeah. So that left hand side లో చూడండి, uh, 2b a omega divided by a into omega naught square minus omega square. a get cancel, అవునా కదా?
Yes,
So 2b omega divided by omega naught square minus
minus
omega. This is the LHS value. What about right HS? F sin theta divided by f cos. Okay, f get cancel, sin by cos is tan. So this equals to tan. Okay, so we go for same thing. Okay na, వచ్చింది కదా? 2b
yes, sir.
omega by omega naught square minus. What is theta value? Tan inverse 2b omega by omega naught square minus. So where theta is the phase value, and let us substitute the value of a, capital A, from 4.5 in equation 4.2. Here a value is there. Okay, which is the 4.2 equation? Here x equals to a sin omega t minus theta. Okay, ఈ equation consider చేయండి. ఈ equation లో let you substitute the value of capital A, f by this. So what you will get? x equals to a, this is the a sin omega t minus theta. So what do you have? X equals to x equals to what is small f అండి? Capital F by m కదా, print mistake చూడండి. Getting my point? This one.
Yes, sir. By m.
అన్ని ప్రింట్ మిస్టేక్లు ఉన్నాయి, చూసుకోండి జాగ్రత్తగా. సార్ ఏం రాసిన మార్కులు ఎత్తాడనేరు. సో x equals to f by m into square root of this one into sin. So this is the final equation. So here what is a? A is the amplitude. What do you mean by amplitude? The maximum displacement of the oscillator or the particle, which you can call it as a amplitude. So here the amplitude of the forced oscillator, which term? This term, which depends on the, where it is depending? Capital F by small f. That means here the entire term which is related to capital A. So that A which can depends upon the F, and also mass of the oscillator, and also here omega is there, sin omega. What is omega? Angular frequency. That is nothing but a driving frequency. That means here the oscillator is doing the oscillations. What type of oscillations? Forced oscillations. And here omega naught square is there. What is omega naught square? Natural frequency of the oscillator. Okay, so these are the terms you have to mention while you are getting the final equation. So the displacement of the forced oscillator, which is going to be depends upon the force, applied force, and mass of the oscillator, driving frequency, and natural frequency. And here the phase difference between the displacement and harmonic force, which can be given by an angle theta, and which is also depends upon the term is there, omega, omega naught, and b. Okay, so here in the case of undamped system, undamped means there is no vibrations at all. So the B equals to R by M is there, na? R by M. So that is called small b. So in this equation, you can write it down that the above equation, which becomes, by substituting these conditions, x equals to capital F by M, uh, which is omega naught square minus omega square. Why? Because of here b is 0 and this b is 0. Condition is undamped. If b is 0, here square root and root will get cancelled, remaining is this term. Okay, and theta is also 0. So that the 4.8 equation becomes 4.9. So that when a periodic force capital F equals to F sine omega t, which is applied to a SHO, simple harmonic oscillator, the drive and force and the displacement, which are in the same phase. Same phase means there is no angle, that is theta equals to 0 degrees. So that you can say here the phase lag, which is essentially due to damping. Why it is going to be damping? Because of there is a phase which is lags the displacement of the oscillator X. That's it. So this is about entire essay question. Up to here, this is for 10 marks essay question. Okay. Only the 3 points you have to remember, and you need to say that what is forced oscillator, and this forced oscillator, the forces, how many forces which can be acting upon this oscillator, you need to know, and by adding all these, which may be equals to the Newton's second law, F equals to ma. So there we have been deriving this equation. This is an important essay. Remember. Next, velocity, amplitude, and velocity returns. And this question is asked short question, not an essay. Question chala sarlu short question కింద అడిగింది. Let me tell you that the displacement of the forced oscillator, final 4.8 equation, x equals to f by square root of omega naught square minus omega square whole square plus 4b square omega square into sine omega t. Here m is represent the f by m kadandi. Okay, so m is represent the mass and the angular natural frequency is omega naught, which is going to be oscillating under the external force. What is the external force? Applied driving force enti f sine omega. So velocity, you know the x value. Differentiating this equation with respect to t, dx by dt is nothing but a velocity. Rate of change of displacement is nothing but a velocity. So by differentiating, sine theta is cos theta. Same thing. This is sine. By differentiating with respect to t, f omega cos theta. This one. And the same thing is going to be realized. Next, cos theta can be written as, so cos omega t minus theta minus pi by 2. So that here you will get cos omega t minus theta plus 90 degrees. Pi by 2 means 90. So that sin omega t minus theta plus pi by 2, which can gives you cos theta. So here sin 90 plus theta cos theta. So like that simple equation parameta చెప్తే మనం ఇక్కడ f omega cos becomes sin omega t, same thing. And also here f omega sin omega t minus theta minus into minus plus pi by 2. So here when the velocity should be maximum for a forced oscillator means if sin theta equals to 1, that means theta value, what is theta value? Omega t minus theta plus pi by 2. So that this you can call it as a maximum velocity of the forced oscillator. So f maximum is equals to, this value becomes 1, so that you can neglect this, the remaining is 4.12. Next, at very low driving frequencies, means a small vibrations are going to be making by this force oscillator. So when it is happened here, if omega is less than that of the, far less than that of the natural frequency of the forced oscillator, then the amplitude here V maximum, which is approximately equals to what is small f, capital F by m into omega by, so the same thing which is written here, k by m. So what is k by m? In previously we have been discussed that.
Omega
Go for
square.
the, yeah, yes. So by substituting mm get cancelled, remaining is f omega by k. So this is for low, very low driving frequency. That means V maximum velocity of the forced oscillator, which may depends upon the applied force, capital. So why? Because of here k is constant, omega is also constant. Next condition is that when f omega is far greater than the natural frequency of the oscillator, then V maximum equals to here f by omega, small f by, what is small f? Capital F by m into here. So in this case, the mass m, that is f by m initial. So substituting, that means at frequencies omega as well as the omega naught, by comparing with this natural frequency, the velocity of the forced oscillator is maximum for a particular frequency. So that frequency you can write it down that here f by m. So by substituting, we will get this equation, and the V maximum will be maximum when the denominator is maximum. So that you can equate it to 0, or you can write it down that omega naught equals to. So that omega naught equals to omega means here natural frequency of the oscillator, which is equals to the driven frequency. So this you can call it as the condition, which you can call it as a here velocity resonance. Velocity resonance, both are same. The velocity should be maximum. That means it can reaches the resonance, maximum amplitude. At resonance only you can able to observe the maximum amplitude. That is the condition. This is the condition. You can able to see here. Maximum is maximum amplitude. That is the resonance. Power transfer. Next, comparisons. Underdamped, damped for damped harmonic oscillator, and forced oscillator. You can go through the previous concept. You can write it down. what are the forced vibrations? Obtain an expression for the amplitude and derive the equation of motion of a FO forced oscillator and obtain its solution. These two are the most important experiments. Go for the, yeah. Another important yeah, vibrating strings. So in this also two questions you may expect. You may expect definitely. So here expected essay question is the velocity of transverse wave in a stretched string. That is the expected essay question. Velocity of transverse wave in a stretched string. So here, what do you mean by transverse wave? Anyone please? Transverse wave. ట్రాన్స్వర్స్ వేవ్ అంటే ఏంటండి? తెలుగు తిరియక్ తరంగం. హలో, ఆర్ యు దేర్? హలో,
సార్
వింటున్నారా?
సార్
లేకపోతే
యాక్చువల్గా
పడుకున్నారా?
లేదు సార్, ఏమడుగుతున్నారు సార్ ఒక్కసారి మళ్ళీ?
వాట్ డు యు మీన్ బై ట్రాన్స్వర్స్ వేవ్?
ట్రాన్స్ఫర్స్ వేవ్ అంటే అంటే ట్రాన్స్ఫర్స్ మామూలుగా వేవ్స్ అనేది ఇలా బేస్ లో రావడం అదేనా సార్ మామూలుగా? సార్ మీరు
ఎట్లా అమ్మా?
చెప్పండి, మీరు చెప్పండి సార్.
మీకు తెలుసా లేదా అని అడుగుతుంది. నేను ఎలాగ చెప్తాను? నేను
ఓకే ఓకే
ఐఎమ్
సార్.
ఆస్కింగ్ యూ దట్ డూ యూ హ్యావ్ ఎనీ ఐడియా అబౌట్ దీస్ వేవ్స్?
వేవ్స్
ట్రాన్స్వర్స్ వేవ్ యాజ్ వెల్ యాజ్ ది లాంగిట్యూడినల్ వేవ్స్. తిరియక్ తరంగము లేదా అనుదైర్ఘ్య తరంగం అంటే ఏంటి చెప్పండి?
సార్
The mode of vibrations of the particle of the wave which is perpendicular to the propagation of the wave, that is called transverse, where you can able to observe troughs and troughs in transverse. Okay, the propagation, that means propagation and in which direction the wave which is going to be propagated, moving, it means carrying the energy. Getting my point? The position of the particle is fixed, but wave means it
మూవింగ్.
includes a particle. It includes a particle, but the particle position is fixed. But the particle can transfer the energy from one to another place, so that the particles which are going to be vibrating here, the vibration of the particle which are perpendicular to the direction of the propagation, you can say it as transverse waves. So in transverse waves, crests and troughs are going to be observed, Srungamu, Dhroni. Whereas in the case of a longitudinal wave, the propagation of the wave which is parallel to the here the vibration of the particles, so that you can call it as a longitudinal wave. So in the case of longitudinal waves, compression as well as the rare fractions are going to be observed. Saralikaranamo, viralikaranam. Sampedita, viralikaranam. Anudargatarak. So you need to know why, because of here longitudinal waves as well as the transverse waves. Pakka expected essay questions ఉన్నాయి ఇందులో. Okay, so that's what here you need to know the basics of these two waves. What do you mean by longitudinal? What do you mean by transverse waves? In case of longitudinal, what? In case of transverse waves, what is going to be observed? So you know this, you can easily derive the equation for. So here, so many expected questions are there. So here, velocity of transverse wave in a stretched string. Stretched string. సాగదీయబడిన తీగ. Okay. That means
Okay, sir.
when the string is under stretched means the tension of the wire which is more. What do you mean by tension? Capital T. మన టెన్షన్ కాదు, ఫిజిక్స్ లో టెన్షన్ చెప్పండి. T equals to tension. T equals to formula mg, where m is the
Mass.
mass and g is the acceleration due to gravity.
Yes, sir.
So here you need to find out here when the string is under tension. That means by applying such a force, external force, the string which is going to be vibrating, that means the energy can carried out through the particle, which includes here where the energy you can able to observe like a here a transverse wave. So the expected question is that one. So velocity of transverse wave in a string. So most of the in as well as in a regular degree as well as open degree, this is an expected essay question. Problematic questions is also going to be coming out from this concept. So that's what I am stressing out in this concept, that you know that let us consider a wave which is going to be propagating from left to right in the string, but the string should be under tension only, the wave which can travel with a velocity or with a speed is v. So here the tension of the string here in this textbook they are saying capital F. And, let you say that here the string as a whole, but it does not move. It only the wave pulse. Okay, wave pulse within a short interval of time, so that which can move along this string here. In this situation, we have to imagine that here the whole string should be moved to the right with a speed of v. So the pulse will remain fixed here. We can able to observe in this space. The particles of the string is also going to be successively progressing from the left to right side. So here, let us consider that a small section of pulse of length is delta L. So which it is going to be formed like an arc of the circle of radius capital R. Arc means a conic section type. So the radius of the circle is a capital R here, and let us consider that mu be the mass per unit length. Mu be the mass per unit length. That means m by L. So here this you can call it as a right, mu equals to m by L, mass per length, and where m is, you can call it as a but here the length is going to be changed here. Why? Because of Here only it is to be saying that very short length pulse. Okay. What do you mean by pulse here? These you can call it as a pulses. Okay. Short interval of time. Yeah. So here the tension of the string, which is a tangential and which can be resolved into two components. One is that horizontal, another one is in vertical component. So here capital F is denoting in this section is a tension here, right hand side as well as the left hand side. The pulse which is going to be moving like this. If you can able to observe that. Yes. Getting my point?
ఇట్లానే ఉన్నారా?
Transverse. Yeah. Transverse. Okay. Like
Transmission.
so, like this here, how it is going to be transferring the energy. So here the horizontal component is cos theta and vertical component is sin theta. So that you can call it as f cos theta is horizontal and the f sin theta is vertical. The total vertical force, that is 2f sin theta. That means you need to write it down, which is approximately the total vertical force is 2f sin theta, or from this figure only what is sin theta means, which is delta L by 2 by r. That means sin theta is, what is the formula for sin and sin theta formula ఏంటండి? Tell me what is the formula for cos theta?
Sin theta.
Opposite side by hypotenuse.
Opposite by hypotenuse. Okay. So here opposite by here, which is making an angle theta here. Opposite by, this is the total delta L, but which is making half portion is, that is a delta L by 2. Okay. And opposite by hypotenuse is from the figure only. So that's what here are delta L by 2 ఎక్కడ వచ్చిందని. So delta L by 2 by R. That is 2 get cancelled, remaining is F delta L by R. This is the vertical force. And here this force which gives rise to the centripetal acceleration of the string particle, and this is equals to the force acting on a mass, that is m delta L, mu delta L of the circle of radius. You can equate, and that is can write it on that. What is m value? Mu delta L mv square. Centripetal force ఏంటండి? mv square by r. Okay. So that centripetal force mv square by r, that is here, what is m and mu delta L v square. This is m by r. Small r is kept. బేసిక్ ఫార్ములాలు తెలిస్తేనే మీకు అర్థమవుతుంది. బై హార్ట్ చేస్తే రాదు ఫిజిక్స్. సో దట్ బై ఈక్వేటింగ్ దీస్ టూ ఈక్వేషన్స్ above and this equation, f into delta L by r equals to mu delta L v square by r get cancelled, delta L get cancelled, then remaining is f by mu equals to v or v square, v equals to square root of f by mu. So here also the velocity v is the velocity of the which can depends upon the two factors. Capital F is the tension, mu is the mass per unit length. Okay, so these are the quantities which can be determined by the elasticity. That means there only Hooke's law and the inertia of the medium, as was mentioned in the we have studied in the case of Newtonian mechanics. There only you can able to read out the inertial part. So here dimensions of the velocity, tension. You need not to write all these things. So here up to here on v equals to square root of f by m. That's it. But wave equation for a stretched state. This is the case. So this we will discuss in tomorrow. I can conclude wave equation. What are the questions we have to discuss in examination point of view? We will discuss. The continuation will go by tomorrow. Okay. Yeah. Do you have any doubts? You can ask. Lakshmi, Deepya, Vinod. Any doubts regarding this? Today's class?
నో సార్ సార్ ఇంపార్టెన్స్ ఏమైనా ఉంటే చెప్పండి.
నేను చెప్తాను ఫైనల్ లాస్ట్ క్లాస్ 29th ఉంది కదా ఆ రోజు నేను ఇస్తాను ఫైనల్.
ఓకే సార్.
ఇంకా మిగతా ప్రీవియస్ క్వశ్చన్ పేపర్స్ కూడా ఏమైనా ఉంటే మన గ్రూప్ ఉంది కాబట్టి ఆ గ్రూప్ లో నేను షేర్ చేస్తాను.
ఓకే
ఓకే
సార్. ఓకే సార్. సార్ దీనికి సంబంధించి కూడా లాస్ట్ సండే పీడిఎఫ్ బాగుంది సార్, మాకు కొంచెం ఈజీగా ఉంది అర్థం చేసుకోవడానికి.
నేను దీనికి సంబంధించిన 4 సార్స్ రైటర్లు ఇదంతా నోట్స్ పెడతాను చూసుకోండి.
ఓకే సార్. ఓకే సార్.
రైట్ రైట్ ఆల్ ది బెస్ట్.